So for this type of question, we are solving a rational equation. P plus 5 over P equals 24 over P minus 5. When solving rational expressions, we realize that the denominators are not the same. So our first step is going to be to make them the same by finding the LCD. In this case, the LCD is going to be P multiplied by P minus 5. We're going to multiply by what it's missing. So in this case, for our first fraction, if we compare the denominator to the LCD, it has a P, but it's missing P minus 5. So we're going to multiply by P minus 5 to the numerator and denominator. In our second fraction, we have P minus 5 in the denominator, but comparing it to the LCD, we're missing P. So we're going to multiply by P to the top and bottom. Now keep in mind that when multiplying P in this denominator, we have to treat P minus 5 as if it's a group and distribute the P. Now, we're going to have everything be the same denominator on both sides. So we'll have P minus 5 on both sides. And our numerators, P minus 5, P plus 5, and 24P. To get rid of the denominators and simplify this a lot better, we're going to multiply the whole equation by the LCD. And this will cancel out our denominators and make it a much simpler equation. So when canceling, simply like that. And all that's left is your numerators equaling each other. So we'll have P minus 5 multiplied by P plus 5 equaling 24P. And now to solve for P, we can FOIL. This is a difference of squares, so our middle terms will cancel out. We'll have P squared minus 5P plus 5P minus 25. That's where our middle terms will cancel out, equaling 24P. And now we'll have P squared minus 25 equaling 24P. We want to make this equal to 0. We have P squared and minus 24P, so or rather 24P here, so we're going to move 24P, P squared minus 24P minus 25 equaling 0. That way now we have a quadratic equaling to 0. Remember, the highest power is 2 in a quadratic. And by doing this, we can find two groups that multiply to get this trinomial. Our beginning, because it has to equal to P squared as the first term, will be P and P here. Now looking for two numbers that multiply to 25 and add up to negative 24 will be 25 and 1. Minus 25 plus 1. And if we have those set equal to 0, what can happen now is we can set each factor equal to 0. So P plus 1 is equal to 0. P minus 25 is equal to 0. And when solving for P, we have that P is equal to negative 1 and P is equal to 25. But because in our very first equation we have that P and P minus 5 are in the denominators, we have to make sure that we're not dividing by 0. So you could choose to do this at the very beginning or at the end of the problem. But just to double check, this right here and this right here cannot be equal to 0 because mathematically we can't divide by 0. So from our first fraction, we have that our denominator can't be equal to 0, so we got to make sure that these answers cannot be 0. We have negative 1 and 25, so we're still okay. Now checking our second, we have that P minus 5 is not equal to 0. When we solve for this, we have that P cannot be equal to 5. Because when we plug P equal to 5 here, 5 minus 5 makes 0 in our denominator. So we have to make sure that our answers are not, P is not equal to 0 and not equal to 5. So our answers, negative 1 and 25, are viable for this problem.